Now let's use the inverse to actually solve a system of equations, something that we looked at in section 5.1. Now let's use the inverse matrix. We talked about taking a matrix, or excuse me, a system of equations, and writing it in the format AX equal B. That format is going to be used when we go to solve a system of equations. The formula you must know is this. That's what we use to solve a system of equations using the inverse matrix. So when you have a system of equations in the form AX equal B, the solution, being the variable matrix X, will be found by taking A inverse and multiplying it by matrix B. Let's just extract that information from this system. For this system, let's write down the coefficient matrix A. So A would be 2, negative 3, 1, 3. Matrix B, the matrix that contains the equal to parts, 5 and 10. And matrix X is our variable matrix. It lists the variables involved in this system, X and Y. So you have to extract that information from the system. Matrix A, matrix B, matrix X. Okay, so that's your first step. Now we can take that matrix A, put it in our calculator, and find the inverse. Well, I tell you what, instead of doing that, we're going to let the calculator do it the whole way. Let's just set up the formula for the system of equations on the previous page. We want to set up X equal A inverse times B. So our matrix X was our variable matrix, was X, Y. Matrix A, so here's X, matrix A looked like 2, negative 3, 1, 3. 2, negative 3, 1, 3. Now we're going to have to take the inverse of that. Matrix B looked like 5 and 10. So I have matrix X is going to be equal to matrix A inverse. We're going to have to take the inverse of that times matrix B. Let's go to our calculator. What we're going to have to put in our calculator is matrix A, matrix B, and then let the calculator find A inverse times B. So let's come over here, clear out everything that we've done. Let's go to the matrix, and let's, under Edit, let's go to A and input this matrix A that we extracted from our system of equations. So we're typing in A. It's a 2 by 2 matrix. And 2, enter, negative 3, enter, 1, enter, 3, enter. So it's a 2 by 2 matrix. We've typed it in. It's all right. So second and quit. So we just put in matrix A. Second matrix. Let's go and type in matrix B. So you always go to edit first, then pick the one you want to edit. And if you notice, B is a 2 by 1 matrix. And let's type in the 5 and the 10 that belongs in matrix B. That's correct, so let's quit. Now, we just placed A and B in our calculator. To find the solution, we need to have A inverse times B. So from this screen, let's go to matrix names. Let's pull up A. I need its inverse times, pull up matrix B. So A inverse times B, that's what I have written on my display. When I press enter, that's going to solve the system for me. Remember, when we come up with decimals, let's change that to fractions using this feature. Oops, happened to hit it twice. What you see is a matrix, a 2 rows by 1 column matrix The first number is 5. The second number is 5/3. Those two numbers represent your value for x and your value for y. Notice x and y is here. I get 5 and 5/3. Those represent my answers for x and y. So the solution to the system on the previous page, found by using the inverse matrix, is 5 5/3, or x equal 5, y equal 5/3. What you will have to do is extract A, put it in your calculator, extract B, put it in your calculator, and then on your home screen type in A inverse times B. That'll give you your solution. So let's practice with this one. Matrix A will look like 5 3 3 2. Matrix B will look like 4 0. So let's go to the calculator, type in A and B. Type them in, then on your home screen type A inverse times B, and we get our solution. X equal 8, and I lost the other one. What was it? Y equal -12. So there's the solution. Just simply put in A, put in B, perform the operation A inverse times B. Do the same thing for the next one. Extract A. Extract B. Make sure. You place A and B in your calculator and do A inverse times B. You should get the values of -1, 2, and 3. -1, 2, and 3. How do I interpret those values? One's for x, one's for y, and one's for z, since we had 3 variables working in this system. 3 equations and 3 variables. So now you can solve systems of equations using the inverse matrix.